Alright, hello Science 10, Mr. Beeland here with your lesson for today. We are going to be talking about collisions, okay? So what is a collision? Well, a collision is an interaction, and it's between two objects, and they physically come in contact with each other. Okay, so a collision is an interaction between two objects physically coming in contact with each other, right? It's kind of what we expect. And during the collision, each object exerts force on each other. Right? They hit each other. So they apply force to each other. And this is dependent, how much is dependent on energy. How much each of them has, right? Remember, if we're talking about energy, in this case, we're going to be mostly talking about kinetic energy, right? And what is kinetic energy? What is it based off of? It's based off of mass and speed or velocity. And this makes sense, right? Because the bigger the car and the faster it goes, the more impact there's going to be, right? You have your coming in really fast and then hitting something that is not coming in very fast. This thing's going to exert a lot more force because it's got more energy. It's going faster. Okay, so we've got basically one thing that we have to consider is in a collision, at least one of the objects has to be moving. And that makes sense, right? You can't really have a collision if the two things are standing still. So you can have two different types of collisions in this case. One where one is moving and the other is stationary. And then the other one where this one is moving and this one is moving. So there's two types. And again, the speed of each of the objects and the direction of the speed, whether or not they're going into each other or if one is moving slower this way, those types of things will affect how much energy is in each of these. So this change, because when they hit each other, there's going to be a change in motion, right? So when they come in contact, there's going to be a change in motion due to collision. So this change of motion indicates that the energy has changed inside the object. Okay, so this also means energy's changed. And what do we mean by that? It could be that some of the energy went from 1 to 2 through transfer. Remember, transfer is when it's the same type of energy, so this would explain why when one car's moving and it hits another, then the second car starts moving. That's the transfer. But you could also have the transformation. And that would be the sound or the heat or thermal energy that comes off of this collision. Remember, though, that in this whole thing, all the energy in car 1 and all the energy in car 2, or object 2, this energy is still conserved. We didn't create anything. We didn't destroy anything. So the energy is still conserved. It's just that some of it's transferred and some of it's dissipated into heat or sound energy, okay? Another good example would be a bowling ball. Comes in really fast, hits the pins, and then you hear the loud bang, and that's where some of that sound energy is basically absorbing some of that mechanical energy. Okay. So there are two types of collisions. Okay, and what I'm going to do is I'm just going to draw. Here's one, and it's going to be moving into two. There's my little speed lines. And then what happens is, now this one's not moving, but this one's moving. Okay, this would be similar to what you might see happen a lot of times at a pool table or something. This is called an elastic collision. When they don't move together. See, one hits and then the other one goes. This is considered an elastic collision. Now, in some cases, and you'll see this frequently with cars. I know it's not a great example, but car accidents. What you'll have happen is, again, you'll have number one coming in to hit number two, and then what happens is they stay together and they move a little bit slower probably, but they still just move that way. And this is called an inelastic collision. Pardon my spelling. Okay, so again, in this one here, as always, energy is conserved. Okay, and kinetic energy transfers. It transfers, but the kinetic energy itself isn't going to be transforming, okay? But so the energy transfers, and then objects do not move together. So it could look like this, where one's moving and now the other one's moving. You could also have a case where you have 1 and 2 and they're moving towards each other, and then what happens after they hit is that they are now moving away from each other. There's a whole bunch of different scenarios. The real question when it comes to elastic is, do they stay together? Okay, are they touching? No, then it's considered an elastic collision. Okay, and the inelastic collision, and this is most cases. Okay, so in this case, right, that kinetic energy will get transformed into other forms of thermal energy. This makes sense because if not all of the kinetic energy, if none of it transformed, then something would still be moving, right? But if we think about, again, let's go with our car here. And this time we've hit a big tree. The tree doesn't really move, right? So what you get instead is that sound and thermal. Okay, so in this case here, right, objects stick together, and your mechanical energy, in this case it's going to be your kinetic energy, has some transformation. In the elastic one, you could possibly, it's very rare, but it is possible that all of your kinetic energy only transfers and doesn't transform. If it was very quiet, no sound, no heat, it's possible, but it would be impossible in this case. Some of it's got to transform, otherwise this tree would be moving, right? Okay, so again, to summarize, collisions, two objects hitting each other, okay? And when we have a collision, these two objects are going to exert a force upon each other, and this is dependent on how much energy they have, specifically their mass and their speed. At least one of these objects has to be moving, And when there is a collision, some of that energy can be transferred and some of it can be transformed. And that is dependent on your two different cases, elastic and inelastic. Okay, that's it. Take care, everybody.